Good evening to everyone. I welcome you all for this 57th weekly online webinar in series of Engineers Talk being organized in commemoration of 30th anniversary celebrations of IEI Salem Local Center. I request the chairman, IEI Salem Local Center, to welcome everyone. Please, sir.
Yeah, thank you, sir. Respected today's chief guest and keynote speaker of the day, Dr. Santosh Kumar Behra, sir, senior scientist, Mindback filling Jharkhand, our beloved honorary secretary, ma'am. Distinguished committee members of both the Tamil Nadu State Center and the Salem Local Center, Engineer N. Armugam, sir, members of Engineers Talk team, friends, participants, and our IEI staff, Engineer T. Thiagu. Good evening, everyone. On behalf of Institution of Engineers Salem Local Center and on my own behalf, I am honored and delighted to welcome you all to this special session of the Engineers Talk webinar series organized as part of the 30th anniversary celebration of IES Salem Local Center. As we know, IES Salem Local Center has been a beacon of excellence in engineering, serving as a platform for knowledge sharing and professional development for the past 3 decades. It is a privilege to host today's event under the aegis of the IEI Mining Division Board as part of our continuing commitment to advancing technical education and collaboration. This evening, we are thrilled to have with us an esteemed personality as our chief guest and keynote speaker, Dr. Santosh Kumar Behra, senior scientist, Mine Backfilling Research Group, CSIR, Central Institute of Mining and Fuel Research, Ministry of Science and Technology, Government of India, Dhanbad, Jharkhand. Dr. Behra's ground-breaking work in the field of mine backfilling research has had a profound impact on the mining industry. His expertise on today's topic, that is the paste fill for underground mines, promises to provide us with a valuable insights into sustainable and efficient mining practices. Heartfelt thanks to Dr. Behra for accepting our invitation and gracing us today with his presence. I also take this opportunity to express my gratitude to the organizing team, my colleagues of IEI SLC, and all participants who have joined us online this evening. Your continued support and enthusiasm are the driving force behind the success of our initiative. That's why we are now in the 57th week. I warmly invite everyone to engage actively in this session, and I am confident that this evening will be an enriching experience for all of us. With this, I once again extend a warm welcome to each one of you. Let us embark on this insightful journey together. Thank you. Jai Hind.
Thank you, sir, for welcoming everyone. Now, it's my privilege to introduce our chief guest and keynote speaker, Dr. Santosh Kumar Behra. Dr. Santosh Kumar Behra obtained PhD from IIT Dhanbad, India. He is working as senior scientist in Mine Backfilling Research Group in CSIR, Central Institute of Mining and Fuel Research, Dhanbad. Dr. Behra has considerable expertise in mine paste backfilling and geomechanics. Dr. Behra has 29 research articles in peer-reviewed journals to his credit. He has conferred with Dr. K.N. Sinha Award 2020 from CSIR CIMFR Dhanbad. He has also received the Inder Mogen Thapar Foundation IMTF Research Award for the year 2021 from IIT Dhanbad. Dr. Behra has completed 70 industry-sponsored projects within a span of 7 years, of which 25 projects in the role of principal investigator. Dr. Behra also received SERB International Research Experience Fellowship for the year 2022-2023. Recently, Dr. Behra was conferred with Kanik Sanman 2024 from BCCL and Dain Bhaskar Dhanbad and IEI Young Engineers Award 2024-25 in Mining Engineer by the Institution of Engineers India. With these words of introduction, I would like to invite Dr. Santosh Kumar Behra to deliver lecture on topic paste fill for underground mines. Over to Dr. Santosh Kumar.
Yeah,
Please,
thank you.
sir.
Thank you very much, sir. Natajan sir. At the outset, let me thank the entire Institute of Engineers, Salem Local Center for giving me this wonderful opportunity to share a few of works what we are doing, particularly on paste fill. I don't know how many participants are from like earth science background or like mining or geology. Okay. Anyhow, I'll okay, whatever time I have been allotted. Just I was discussing with Thangra sir. He told me that it will be like 30 minutes and it will be around maximum 45 minutes. So I will be briefly explaining everything about paste filling for mining application. Those are directly linked with underground mining. They may find it very much interesting. Okay, anyhow, I will try to make it interesting. Straight away, I am sharing my screen. Yeah. Hope my presentation is visible to everyone.
Yes, sir. Visible, sir.
Yeah. Okay. So paste filling, it is one of the most advanced backfill technology so far as underground mining is concerned. We know this is all about underground metal mining. I'll be speaking about underground metal mining particularly. So if you see the history of mine backfill, particularly in underground metal mines. So earlier, like before 1950, mining industry, the underground metal mining industry, they started with uncemented backfilling. Uncemented backfilling means simply whatever voids are created after extraction of ore. Those voids, the stopes are backfilled with either sand or simply development waste rock or aggregate without adding any cement. Okay, then later on, with the progress of time, with the need of production and with the need of increased safety and also productivity, people started thinking about adding some cement to the backfill so that the backfill mass attains sufficient strength after certain period of time. So there are plenty of advantages when they are going to there is a transition phase from uncemented to cemented backfill. I will be explaining what are those advantages. So to categorically divide various cemented backfill methodologies, we have cemented hydraulic slurry backfilling in a slurry form, if you add some cement to that uncemented backfill, and also cemented rock fill. During 1960s, it has been widely used, and then cemented aggregate fill. And the last one in the bottommost slide, it's like cemented paste filling, and simply we call it paste fill. First time it was introduced during 1980s in Germany. Then later it was fully established and used in a underground mines of Canada. And slowly throughout the globe, people started using paste fill technology for their underground mines. So, what are the different how we select what should be the best best backfilling method for underground metal mining, depending upon the production requirement and what kind of cost the mine owner is going to bear, depending on the capital investment and what kind of operating cost they can bear, and the level of operation in the underground mine environment they need, and the maintenance up to what extent they can maintain their best operation, and also considering the risks associated. The risk means both considering the technical, financial, and also environmental risk associated with backfill operation, and then considering the environmental impact. Considering all those parameters, the best suited backfill method is decided. Like as I was telling, just this is the schematic of what is the purpose of backfilling in underground metal mine, and why we do backfilling in underground metal mines. In the top figure, you can see this is schematic of a cut and fill operation, where you can see there are some extraction operation is going on at the bottommost slice, you can say. And for example, if we are moving from bottom to top in a upward direction. Okay, so what usually it is being done? Usually it is like the bottommost portion is extracted, then it is backfilled with suitable material. Then we in a bottom of extraction sequence, we move in a upward direction. Okay, like here you can see the bottommost slice has already been backfilled, and also the next slice you can see it is been backfilled. The third one also backfilled, and above the backfill must extraction or production is going on. So this is one method of backfilling. So like if you say the one purpose of backfilling is like to create a working floor. One purpose, create a working floor for operation. This is one purpose. Another purpose is like to provide a improve the local stability of the underground workings. The second purpose. Third purpose, like I will explain in this primary secondary stope extraction, like in the sublevel stoping, what it is being done, like the block is divided into certain stopes. Then they name it is like primary and secondary. In between two levels, they drive intermediate levels. And within these levels, they divide the ore block into different stopes. They call it primary and secondary stopes. Initially, they either they start from the center line, or from one end, then they move to other end, or they from the center line they move towards both the directions. So depending upon the work condition, it is being decided. So what does the primary stope means? Primary stope means it is the first stope which are extracted and backfilled. Then the primary stopes are extracted and backfilled in a sequential manner, and the secondary stopes are kept intact. And in the later stage, when all the primary stopes are backfilled in a systematic manner, in a scientific manner, the secondary stopes are further extracted and backfilled. Depending on the requirement, they in the secondary stope, either they can go for cemented backfilling or uncemented backfilling. Depending upon the site requirement, it has been decided. So here, what I was telling, the purpose of backfilling. Okay, the purpose of backfilling here is the primary stope. Whatever void created in the primary stope, that should be backfilled, and the backfill mass. The backfill mass, here also you can see the backfill mass. The backfill mass should remain self-standing when it is exposed along one side. Okay, that means when you are extracting the adjacent secondary stopes, you are creating a complete void. Say the height of the stope, for example, say it may be 25 meter, 30, or even 50 meter. So the entire 50-meter backfill structure should remain intact, and that should not fail when it is completely exposed along one side. This is one more objective. Okay, definitely it provides some ground support to the underground working, and also it facilitate and improves production of the underground mines. Like you imagine that say for a mine you are not using backfilling. So in that case, what you will do, you will simply extract the primary stopes and you will leave some ore in form of ribs or post pillar to protect the ground. So in that case, like if you talk about the differences of the percentage of extraction, in that case you may extract say 50%, 60% of even only up to 50 or 60% without backfilling. So in this method, when you are going for cemented backfilling with primary secondary, in that case you are not going to leave any ore blocked in pillars or reefs or stopes. You are going to completely extract the ore within two intermediate levels. That means complete extraction in between two levels. That means 100% extraction in between two levels. So you compare with the conventional unsupported unbackfilled methods where you are only getting 50 to 60% maximum. And whereas in with the cemented backfilling, you will get 100% extraction within two immediate levels. And also now there are plenty of advancements have been done even like to completely extract the ore even without leaving any also like crown pillar. Okay, like even crown pillar is to be replaced with cemented backfill. So this is just about the what are the benefits backfilling provide to underground mining industry. So this is how different studies we do to what should be the strength, the required strength, so that the backfill mass remains stable. This is a case for a sublevel stoping with paste filling. I will not explain in detail about what kind of studies we do. This is just a simple illustration where we use numerical modeling techniques to determine the design strength for the backfill stope. These are the various finding of the numerical modeling. So all those things we do. Like coming to what are the advantages and disadvantages of conventional hydraulic fill? When we're talking about hydraulic filling or cemented hydraulic filling, and when we are comparing with paste filling, what are the advantages and disadvantages? Definitely, that hydraulic filling has a lower capital cost and also lower operating cost, and also like friction losses are also lower, and like hydrofill plant is easy to operate. And in term like if you talk about advantages of hydrofill, only one advantage is you can see like only you are spending less money. Other than that, there are no much such advantages. There are plenty of disadvantages in the underground mining scenario. There will be additional underground dewatering equipment is required, and also hydraulic barricades need to be very hard, and there is always a risk of failure of barricades, particularly in hydrofill operation. And if you ask any mine manager what you need, hydrofill or paste fill, then the mine manager will say straight away like I need paste fill, because of all merits what paste fill will provide. So these are the different backfilling methods, rock fill, simply rock fill, what I was telling in my second slide. Like whatever development waste rock it is dumped in the usually rock fill is being done in secondary stopes, and if you add some amount of cement and minor amount of water, so that a rock cement water mixture kind of thing is made, what you can see on the rightmost side picture is called a CRF. And CRF is like unsaturated, uncalcified rock. So whatever development waste rock you are getting in the underground mine, simply you are adding cement and water to that, and you are pouring it we are dumping it in the stopes. This is CRF. When you classify the material, classify the waste rock, depending upon the size requirement, then it is cemented aggregate field. Like whatever waste rock, say it has been decided that okay, the waste rock should be in the size of the waste rock should be in the range of say 10 mm to 10 centimeters. So accordingly, you classify the rock, then mix it with cement and water, then dump it in underground stores. So these are like how the evolution has been made, like waste rock, simply waste rock filling, then adding some cement and rock filling, then further classifying the rock fill so that a classified aggregate fill is made, that is cement and rock fill. So in the left photograph, you can see hydraulic slurry backfilling and cemented hydraulic slurry backfilling. In both the cases, there will be some water will be deposited on the top surface of the fill mass. This is called as decant water. Normally, in hydraulic filling operation, in this figure, what you can see, the filling is being done from the upper level through a pipeline. Normally, the hydraulic fill is prepared in a surface hydrofill plant. Then from the surface hydrofill plant through underground boreholes and pipelines, the slurry is transported to the stove. And in the upper level, normally the pouring is done. And at the bottom level, it is open, so a barricade is constructed, like a retaining wall kind of thing is constructed at the bottom level, so that the entire material is contained within the stove, and there is no leakage of material through the barricade. So the purpose of the barricade is to retain the whole the material within the stove, and this height of the stove, it varies mine to mine. In some mines, it may be 25, 30, even 50 meters. Okay, it depends upon the site requirement. And normally, in the bottommost portion, say up to 7-meter height from the bottommost level, a backfill plug is constructed. Plug means relatively higher cement backfill mass. And above that backfill plug, relatively lower cement backfill is poured. And the purpose of this construction of backfill plug means the purpose of this plug is that it will sustain the entire overlying load of the backfill. And as it is of higher cement content, so there are less chance of this hydraulic fill mass failure and hydraulic fill mass leakage through the barricade, even after the barricade fails. If once the backfill plug is properly constructed, that means there will be the chance of backfill mass failure is negligible. This is what I was saying, like how the like backfill is prepared. This is just example of how paste fill is prepared in paste plant. Normally for paste fill preparation, a surface plant is used for paste preparation. In that plant, classified mill tailings is used, then cement is added and water is added. Depending upon the requirement and design, the paste is prepared and the paste is dumped. The paste is transported to the underground through boreholes that connect from surface to underground. And from the underground portion, by using different pipelines, reticulated pipeline network system, the paste is poured up to the stoves, whatever required. This is overall the process of backfilling. This is like different studies like we use particularly for like hydraulic filling or cemented aggregate filling. Like there are different materials is used depending upon the site requirement and the availability of material. This is just example, like earlier I was showing of tailings. Now this is about water mass and also overburden, and also like classified overburden of different sizes, like the finer fraction, like less than 10 mm, like it can be used for hydraulic filling, and the coarser fraction, like more than 20 mm, they can be used for cemented aggregate filling. So these are the various studies we do, like depending upon the so if we are doing hydraulic filling, the main objective is like the material should attain sufficient strength. At the same time, the material should not remain in a slurry form for longer period of time. So whatever water you are adding to the underground stoves, the water should come out of the stove through the decantation pipes. So what these are the like laboratory setups. So we do physically simulate those things in a lab scale before implementing before suggesting any backfill material for hydraulic filling and for underground stove filling. So this is one of the like hydraulic filling plant of a mine site. And the top most you can see the hydraulic filling plant. And in the bottom portion, you can see the backfill barricades and also how the pouring is being done in the underground stoves. This is one more one of the most advanced hydrofill plant of Hindustan Zinc Limited, which uses tailings, cement, and water. And particularly in this hydrofill plant, like the solid fraction is almost like 70%. It's the same high concentration hydrofilling plant. There are various components which are used in hydrofill plants. So far as the tailings is concerned, agitators are used, and in hydrofill plant for the tailings based hydrofill plant, the mixture is somewhat like a vertical mixture. And in hydraulic plant, the pump is normally a centrifugal pump. And this is also one old hydrofill plant of a mine. And one part is like, as we are talking about hydrofill, and the barricade should be designed in a properly so that the backfill mass is retained within the stove. And like various factors need to be considered, like what are the loading mechanics on the backfill barricade, and what is the strength of the barricade, and based on the what should be the load acting on the barricade, and what should be the strength of the barricade, and the backfill barricade is designed. So this is the reinforced composite shortcut backfill barricade construction, which is under construction. Just a photograph. And there are like different backfill barricades that can be constructed. Like it can be a like shortcut composite barricade, or like simply a brick based structure, or simply a wooden structure, depending on the site requirement is being decided. Like what should be the benefit if you're creating a stronger barricade? That means you can increase the fill pouring rate, and you can continuously you can pour paste fill or backfill. And also like you can use wider stoves. So if you are using wider stoves, means you are producing more ore at a time. And definitely it will add some safety to the underground working. You can continuously fill it, and also the risk of like failure of the barricade is minimized. This is one more figure of wooden plank barricades. And this is what I was telling, like various decantation pipes, which are erected from the upper level to the lower level, so that whatever water is there inside the stove, that water comes out of the stove through these decantation pipes, and the water is minimized. Water level is minimized in the underground stoves. This is one photograph of another type of barricade. Earlier, I have shown wooden barricade. Now, this is one of the most advanced barricade construction, like reinforced double layer, reinforced circuit, and also fiber reinforced circuit composite barricade. And also, you can see there are many drainage pipes which are kept to drain the additional water which are present in the stove. So now, earlier I was just explaining about brief of cemented rock fill, cemented aggregate fill, rock fill, and also hydrofill. And now coming to paste fill. So if I just compare with hydrofill and paste fill, the paste fill consists of high solid content, whereas hydrofill consists of lower solid content. High solid content paste fill means up to 80% solid, whereas in hydrofill means low solid means only maybe it may be up to 50 or 60% solid. And also in terms of particle size, in hydrofill it is better to use a backfill material which have lesser amount of fines, whereas in paste fill the material should have sufficient fines. Sufficient fines means particle size means less than 20 micron, has to be 20%. And during the bleeding means separation of water from the solid material, that should be minimum. And during the transportation of paste from the surface paste plant to underground, during the transportation, that should not settle or segregate within the pipeline, and normally it contain high solid. So in the right figure you can see the paste fill, like it's something like a toothpaste kind of thing. Now, why paste fill is required? Though industry is having like hydraulic filling, and also people are doing hydraulic filling, cemented hydraulic filling, but it was the need of the industry that they should improve, increase production, at the same time increase safety, and at the same time whatever tailings is generated from the mill, that should be disposed in a large volume. So considering all those various issues, and also there are n number of limitations of hydraulic filling, and one more requirement is like the stoves, the voids what are being created, that need to be backfilled quickly. That means a high rate of backfilling is required, and even to extract or below important surface constraints, surface features. So considering all those requirements, people started using paste filling. And advantages, you can quickly see that there is a minimization of the handling of additional water, and better quality of fill in terms of hydrofill. Quality means in terms of strength, in terms of dilution, and also reduction in mining cycle. And for example, if we're doing hydraulic filling, the entire stove filling process, in some instances which may need say for example 30 days for filling a single stove. If you're using paste filling, the same stove can be filled within 10 to 15 days. So straightway you are reducing the mining cycle by 50%. And also it prevent the possible liquefaction, and it create paste will create less pressure on the backfill barricades. So what are the various materials, particularly for underground metal mines? Those can be used for paste fill preparation. This is a study we did by mixing mill tailings, fly ash, and also crushed slag and cement. And there are the various laboratory studies we do in Simper. And this is the scanning electron microscopy of SEM study of the tailings and fly ash and other materials. And what is the major chemical composition of various tailings? What we studied, this is this one Behra et al. This is a lead zinc mill tailings. In generally, the tailings are composed of silica, SiO2, then Al2O3, Fe2O3, some amount of NGO, CaO, and also SO3. So there is a role of the chemical composition on the backfill strength. Like if we have higher proportion of CaO, SiO2, and MgO and others, the strength is better. Whereas the SO3, if you have higher proportion of SO3, it may create some negative impact on the strength in long run. So like there are different studies we do, like comparing with hydration index and lime saturation factor. And there is one part what also we did for a particular mine, earlier that mine was using cement as a binder, as a cement as a complete binder. So normally in backfilling application, if you are simply using cement as a sole binder, that means you are spending more, and backfilling is itself a costly affair, out of which 75% is the binder cost. So if you are using only cement as a sole binder, so the target was to reduce the backfill cost and to use alternate binders so that cement can be replaced. Similar to that of the concrete in civil engineering, similar to that of concrete. Like even in concrete also, like people are using alternate binders like GGB, FS, fly ash, and other natural and artificial pozzolana. Same thing is applicable to this paste fill also. So we found that when you are replacing the cement by 1 to 2% only, we are saving crores of rupees on an annual basis. So this is one of that study. And another part is like paste backfill performance. Paste backfill performance when it is backfill, means after certain days, after certain curing time, what is the strength developed in underground backfill stoves, in underground backfill mass. So in this figure, you can see like this is something like artificial rock kind of structure is made in underground stoves. You can see a setup is used to extract core samples from the backfill mass. So imagine that a strong backfill structure has been created in underground. Okay, unless you create a strong backfill structure, you cannot extract core from that backfill mass. So it is simply so if you are able to extracting a core, that means the backfill mass has attained sufficient strength. And also that strength, the purpose of this core extraction is like to determine the strength parameters of the cured backfill in underground environment. So this is one kind of studies we have done for many mines. So this is another part what I have seen, like we have extracted a block of backfill mass. This is a backfill block of backfill, not a rock backfill. And in the lab we extracted cores, and you can see the cores. It is it looks like rock cores, but actually it's cured paste fill cores. And then we determine various properties like UCS, tensile strength, and also Young's modulus and Poisson's ratio. This is what we did. There are like one more study we did, like replacing the cement with fly ash and GGBFS, granulated blast furnace slag. These are the various properties of the material, whatever you have used, like tailings, fly ash, and GGBFS. And like one more, recently people have started thinking about using paste fill in conjunction with the waste rock in a single stove. This is one part also we are working on it. How best both the things can be accommodated in a single stove, like paste fill at the same time waste rock. So we are working on this also. And this is just a for some portion of the mine it can be done, not in a complete level. And this is all about like waste rock core disposal. Okay, so I have just quickly gone through because I have completed my slides. I will just summarize whatever I have explained. Quickly, I have explained different underground backfilling methods which are being used. All these things are used in India and in various underground mines of Hindustan Zinc Limited, Indian Metal and Ferroalloys, Hindustan Copper, Uranium Corporation of India Limited, UCIL, then MOIL, and also like Indian Metal and Ferroalloys, I have already told, and so like Odisha Mining Corporation, people will be using paste fill. So I have summarized different methods of backfilling, starting from uncemented to cemented backfilling, and also in the cemented backfilling category, we have different options like cemented rock fill, cemented aggregate fill, cemented hydraulic fill, and paste fill. And I have also differentiated like what is rock fill, then CRF, cemented rock fill, and cemented aggregate fill. Then I explained quickly. I explained about what are the process of for doing cemented hydraulic filling and what are the merit and demerit of cemented hydraulic filling. Then I quickly explained the benefits of using paste fill over cemented hydraulic filling, and few studies on paste fill and how tailings can be used for paste filling purpose, and how the cost of paste fill can be reduced by using alternative binders, replacement of cements, and at the end barricade design, how barricade is being constructed, like, and what are the different materials which are used for barricade construction, like even the conventional wooden barricades, and also like brick barricades, and the recent like reinforced shortcut barricade. All those things quickly I have gone through because of lack of time. Like it was like only 30 to 45 minutes. That's why quickly I summarized everything in a single lecture. If anybody is having any doubt, any clarification in detail, they can ask me here also. Even they can call me or they can mail me. I have my email ID. While I'm just going to that. Okay. This is all about from my side. Hope I have not consumed much time. Whatever time has been assigned to me, I have finished within that time. Any questions from the audience, sir, please?
Sir, in the chat, there was a
Yeah.
question. What are all
Yeah.
the job opportunities available to the students who are opting for mining related engineering courses?
Yeah, right. Yes. Actually, even I was also guessing there might not be many listeners who are from mining background. Okay, so okay. Anyhow, mining related, if anyone is doing diploma mining or BTech mining or BE mining, like straightway, say for example, if someone is doing BTech mining from any university, whether it is private or government. So the first part, like in mining industry, industry need mining engineers that for different operations. Like it is being categorized into two parts. One is like underground, and other is open cast. So there are plenty of scope of job in mining. Like there are many PSUs. Say for coal, we have Coal India, and also Naval and Ignite, Singareni Collieries, SCCL. And in Coal India, we have different subsidiaries depending on locations. This is all about coal. And also coal, like private players are also there, like Adani, Reliance, Birla. Like you name the richest person of India, they are having coal blocks. Ambani, Adani, everyone is having, even Birla, Tata, all are having coal blocks. So one part is also there, like they can work there also. And this is all about coal mining. And in metal mining, PSUs like Hindustan Copper, Uranium Corporation of India Limited, UCIL, and like MOL, Manganese Ore India Limited, MOL, and private players like Vedanta, Hindustan Zinc Limited, and also I forgot to mention like National Aluminium Corporation, NALCO, and also like private players like Balco, Bharat Aluminium Company, and there are many private industries like Indian Metal and Ferrous Alloy, Tata Steel, and also Vedanta, Pekar, and this is like just a brief of that. And also one more part is also comes under mining, like Indian Rare Earth Limited, like for beach pleasure mining. Like in Tamil Nadu also, huge deposit is there for beach pleasure mining. In Odisha, in Tamil Nadu, they have operations there. IREL, Indian Rare Earths Limited, and like there are plenty of jobs. Like what I can say, if someone is doing BTech in mining, definitely he will get a job. That what I can say. Even the diploma mining holders, they will also get a job. Getting a job in mining industry is not a difficult one. They can even even it's like average student or even a below average student, they can easily get a job in industry. This is hope Thangra sir. Am I clear, sir?
Yes, sir. Clear, sir.
Okay. Shall we conclude, sir?
Sir, I have few doubts, sir. This is Mohan
Please.
Kumar, sir.
Please,
Pardon?
sir, carry on.
Sir,
Yes.
is there any seepage problem will be possible, sir, due to this paste backfilling? Water seepage.
Water seepage. Water seepage from what? From backfill mass?
Yes, sir. Yes, sir.
You are talking about water seepage from the backfill mass.
Yes, sir.
Particularly,
Right, sir.
yes, particularly in paste fill, what I was telling you about, the separation of water from the backfill mass has to be minimum. Say minimum means it's up to 5% only. So we are adding, say 20 to 25% of water to the underground stove. Say out of this 25% of water, normally studies have been found that 12 to 15% of water is being used for cement hydration, because the volume of the backfill is very high. Very high means imagine like a stove of dimension of height 50 meters, width maybe 30 to 50 meters, and length also we same like 20 to 30 meters. So it's like a huge volume of backfill is poured, and whatever 25% of water is added, out of that 12 to 15% is consumed during cement hydration, and whatever bleeding water is there, separated water, what we are taking about seepage water, it comes out of the stove through the barricade, through the decantation pipes, drainage pipes. Okay, so say the seepage water, the separation of water will be there up to the filling process, and even up to say 3 days or 4 days after the complete filling of the stoves. And it will not like beyond 7 days, there will be no seepage water. So whatever water will be coming out of the stoves, it will be only up to 7 days. 7 days of complete filling. Okay. After 7 days, there will be no water coming out of the stoves. And whatever additional water will be coming from the stove, that means that water is not from the backfill. It may be from the ground, okay, from the rock, okay, from the cracks, joints of the rock. The groundwater may be coming out of the backfill through the drainage pipes. Hope I'm clear. Mohan Kumar, sir.
Yes, sir. Yes, sir.
Is there any doubts? Okay. Well, thank you very much, sir, for your wonderful presentation on mining. And I would like to invite Honorary Secretary, IEI Salem Local Center, to propose vote of thanks.
Thank you, sir. I'm audible, sir.
Thank you, sir.
Yeah, yes, ma'am, you're audible.
Most respected, our chief guest and keynote speaker, Dr. Santosh Kumar Behre, sir, and our respected Chairman Dr. K. Dangaraj sir, Mr. Arumugam sir, Mr. Thiagu, most respected committee members and council members, students, faculty from various organizations. Very good evening to one and all present here. It's my great pleasure to propose vote of thanks in this great occasion, 57th webinar series lecture in the topic paste fill underground mines. On behalf of each and everyone, it's my great pleasure to propose vote of thanks to our chief guest and keynote speaker, Dr. Santosh Kumar Behre sir, senior scientist. He is senior scientist, mine backfilling research group, CSIR. From Jargand. Actually, we received extraordinary information, sir. You have given lot of information about the mining. It is our fortunate we are here from you about the information. Actually, though we are the technical person, this is the new to us about the mining. Thank you for accepting our invitation and grace the occasion, sir. Thank you so much.
Thank you, ma'am. Thank you.
Thank you. And I would like to thank our chairman, sir, Dr. K. Tangaraj, sir. He is always very motivated us for conducting like this programs. So thank you very much, sir. I would like to thank the members, engineer stock members, Dr. A. Kumaravel, sir, Dr. R. Satish Kumar, sir, Dr. Engineer K. S. Selvam, sir, and Engineer N. Arumugam, sir, for always rendering the support, needed support always. And I would like to thank Engineer N. Arumugam, sir. He is always supportive for conducting all the seminars without any hesitation. Thank you very much, sir, for extraordinary support. And I would like to thank Mr. Thiagu. He is the single point contact for our IEI office, Salem Local Center. He is coordinating all the seminar in successful way. Finally, I would like to thank all the members, council members, committee members, students and the professors from various organizations for active participation and grace the occasion. Thank you one and all present.